Now recording. So, I'd like to start today by cleaning up a couple of topics that related to sessions that we didn't quite have time for last week. Then we will be on to databases. So, session security. Session security is very, very important. Can anybody take a guess? What are the possible consequences if your session ID falls into the wrong hands? What happens?
Someone can essentially take over your account.
Someone can take over your account. It is possible, yes. Especially if if the website that they have the ID for doesn't take added precautions to prevent such things. What were you going to say?
Actually, the same thing.
Same thing?
Yeah.
Well, you would be equally right. So remember that the session ID, which is stored in a cookie on your computer, is your way of telling the server, I am the person that you just authorized. If that random number becomes known to someone who knows what to do with it, what they actually can produce on their own system is a duplicate session, right? You can have two computers, both with the same session ID. The server can't tell the difference between them. This is, of course, a problem. An attacker can use a duplicated session to steal important information. You can imagine being logged into your bank, right? If you're logged into your bank and someone has that session ID, they can do all of the actions that you can do without having to re-enter your password. Now, there are a few different types of attacks, of course. Some types of attacks will attempt to grab your password. There are various things you can use to do this. One of the easiest ways is to produce a keystroke logger on the login page of a website. You can do this by loading JavaScript that isn't supposed to be there. This is the type of thing you can do when that website has a cross-site scripting attack vulnerability. You guys did cross-site scripting attacks in the first half, I presume?
Yeah.
Very good, very good. So, when you have malicious JavaScript which is running on a website where it's not supposed to be, one of the things it can do is log every keystroke that a person makes when they're, for example, logging into their bank. If you have one of those, and you can very easily reconstruct someone's password by monitoring their keystrokes. If they have your password, that is a big problem, right? Because then they can use that password to do anything they like with the account. Having your session ID is less serious than that, but still quite serious, right? Typically, when a website, when you request a password change on your account, or any major change on your account for, an average website, if the security is good, they will ask you to re-enter your password. The purpose of doing this is that someone who has your session ID number does not necessarily have your password. If all they've done is they've done some kind of man-in-the-middle attack or something like that, they've got your session ID, but they don't have the password itself, they can do a certain amount of damage, but they can't go so far as to lock you out of your own account, right? This is a better state to be in, but still not the best state to be in. The best state to be in is you don't have anybody attacking your account, right? So, so there are some things we can do as programmers of the server to try to stop people making full use of session IDs should they fall into the wrong hands. Unfortunately, some of this is vulnerability in the internet infrastructure itself. We as server programmers cannot prevent a man-in-the-middle attack. Do you guys know what man-in-the-middle attacks are?
Nope.
I heard a few people say nope, so here we go. So the internet is composed of a bunch of computers networked together, right? We call them network nodes. So if you imagine the internet as this vast connected network, much larger than this diagram, of interconnected computers, right? Your data packet, as it travels through the internet, will pass through some combination of the nodes in the network. Now here's the issue. Not all of these nodes are going to be trustworthy, right? These are like computers which are privately held by, in some cases, in most cases companies, but in some cases private individuals. So, this node right here could possibly be owned by a hacker. So, when a hacker is intercepting your network communication, while it's in the network itself, it's called a man-in-the-middle attack, right? Your data packets go in, your data packets come out. This guy is sitting in the middle of that, man in the middle. Make sense?
Yeah.
So some of the things that a person who is sitting in the network like this can do, basically they can't do much unless they can decrypt your packets, right? The whole purpose of using HTTPS, S for secure, is that the packets are encrypted. The packet payloads are encrypted anyways. Without the ability to decrypt the packets, the man in the middle can't access the data inside of the payload, right? Now, let me ask you a question. When we send username and password information, do we use get or do we use post?
Post.
Why do we use post? Because it's secure. Where is post data stored in the packet? Okay, so you've got two regions of the packet, right? You have the header, and you have the payload, right? The payload, as I just said, is encrypted. That's supposed to be a lock. There you go. Encrypted. The header is not encrypted, right? The header can't be encrypted. The purpose of the header is to contain the information that the packet needs to navigate the network. Things like, where am I going? Where am I coming from? Right? If the network nodes didn't know where the packet was going, they wouldn't be able to send it there. Right? So a certain amount of the packet must be unencrypted. Right? When we send get parameters, right? Where do they get sent? Where do you put them?
We have
In the header, yes. You attach them to the URL, right? The URL is part of the unencrypted header. So, get parameters that you send are fully visible to everyone on the internet. Fully visible to everyone on the internet. So, do we send username password combinations using get parameters?
No.
No.
No, very good. Yes, we send them encrypted. Post parameters are sent in the payload. That's right. They're sent in the encrypted payload. So, your average node in the network cannot decrypt them, cannot yoink your username password combination. Does that make sense? Good. So the problem, though, is a little bit about how encryption works on the network. Have you guys have probably seen this diagram? You guys have seen this diagram here? The TLS handshake? Yeah. Probably in intro networking, right? Yeah. Show me this open image. Where is it? There we go. Boop. There we go. Nice and big. So, the TLS handshake is the process by which the client and the server agree on an encryption key. Right? The encryption key is the thing which the hacker doesn't have. It's the thing that you use to expose all of the information in the payload, right? But, here's the thing, and here's the wicked thing. If you have some random client and some random server out there on the internet, how do you establish a mutually agreed upon encryption key between the two of them without the network?
The network, maybe install a certificate.
Well, certificates themselves are also encryption keys,
Yeah.
right? So there's no way for the client and the server to communicate an encryption key except using that very same network, right? The client and the server cannot magically, use telepathy to agree upon an encryption key and then use the network for the rest of it, right? The establishing of the encryption key itself is also network communication. If the TLS handshake passes through an enemy node and the enemy is sufficiently savvy and sufficiently quick to catch it, a man-in-the-middle attack can breach this guy. It's difficult to do because of the nature of network architecture, and also it's in everybody's best interest for cracking this to be as difficult as possible, right? But if the TLS handshake itself is compromised, which is possible, the encryption key can become known to the attacker, right? Which means the payload might be decryptable, right? Which means, basically, as a person who develops web applications, both on the client side and on the server side, you can do nothing wrong, and you can still have a vulnerability, right? The network itself can provide an attack that you can do nothing about, right? That being said, there are mitigation strategies. All security should be seen as a series of deterrents, right? We can't guarantee absolute security. It's not possible in computers or any other domain, right? You have a house. You have stuff in your house. You don't want people stealing your stuff. You lock the door, right? Doesn't stop someone who can pick a lock, right?
Yep.
You have one of those like sliding deadbolts at the top of the door, right? You engage the deadbolt, doesn't stop someone with a crowbar, right? You've got steel sheeting that comes down and clamps down your doors and windows just like in a cartoon. Doesn't stop someone with a sufficiently hot blowtorch. You take all of your stuff and you put it on the moon. Doesn't stop someone with a space program, right? There is no such thing as absolute security. All there are a series of increasingly strong deterrents. Yes?
If you are the client and the server, can you just manually set up the encryption method for both so they never have to communicate it?
Yes, probably, but you'd have to get pretty heavy into the software running. Like you'd have to probably make your own modifications to the server software. Plus, that would mean that anybody who's not you connecting up wouldn't be able to. However, you can certainly see applications for that, right?
Like I was just thinking in a company office, we have like multiple computers just setting up to a server.
Or, not to make things too serious, but military applications, right? I don't know that much about how the military's Wi-Fi works, for legal reasons, but they do have like a special dedicated wide area network which is only for use by military machines. My wife's actually in the Naval Reserve, and they have these special laptops. They connect to a regular network, right? But the wide area network they're connecting to is like the special government armed forces network, right? It's actually a chargeable offense to plug a USB into them. Just a general USB device, even a mouse, these things basically are configured that if anybody ever attempts to use the USB port, which is like non-authorized military hardware, the computer sends out a panic signal, and military police come in on your location and seize both the computer and you go to military prison. That's a thing that's actually true. That's happened to people she knows. So it's they're if you sometimes hear old professors talk about a thing called sneakernet. You know what sneakernet is? That's where you put files on a disk and you walk it over somewhere else and you put it in a machine. Sneakernet, right? Yes, there are ways that we can do these sorts of things, but in a normal civilian context, and for us, generally speaking, everyone in this room should be trying to make a website that your average normal person would visit, which means we do have to worry about security. Yeah. Very good question, though. Thank you. Good. So, mitigation strategies, then. Let's assume that we are trying to address people stealing our session ID. All right? That's the problem we're trying to mitigate right now. It might seem like all of these will seem like simple common sense things, but sometimes the simple solution is the best solution, right? Consider what your session expiration time is. The default is 21 minutes. Maybe that's a bit too long. The longer it takes your cookie to expire, the more time the hacker has to do damage before their cookie expires as well. So when someone steals a cookie, they don't always have the ability to regenerate it, right? it depends on how things are configured, right? So, setting the expiration, oh sorry, default is 24 minutes, not 21 minutes. If you set the expiry to be shorter, then that provides less window. I think in cybersecurity, the term they use is attack surface. Session hijacking prevention, well, you know, if you were passing a session ID around in the URL, don't. It should go in the encrypted payload. Don't put it in the header, number one. You should never have considered doing that in the first place. Yes. Some of this is kind of like client-side, user-side stuff. Don't connect to sensitive things on unsecured Wi-Fi networks, you know. Like Wi-Fi is a radio signal, right? If it's a radio signal, you should consider everything you load up on the internet via a Wi-Fi connection to be broadcast to everything in range of the Wi-Fi connection, because that's true, right? Which means that you're probably not the only one listening. If it's, they talk about like airports and that sort of thing, right? You should definitely have everything configured to use HTTPS. You should use encryption. That should go without saying. Use secure session configuration settings, such as cookie secure and strict mode, and HTTP only, to mitigate risks from XSS attacks. So mitigate, but not obliterate. As I demonstrated in the last class, these are these checkboxes that I showed you in the last class, right? HTTP only means that in theory the cookie can't be loaded from JavaScript. If that's not there, then it's very, very, very easy to access a cookie from JavaScript. It's literally just cookie dot cookie name, and that you get the cookie value in JavaScript. So in theory, that prevents it, but also in fact, that setting can be easily modified. So, once it's on the client's machine, there's no way for you to secure it. Never trust the client. All right? Regenerating session IDs periodically or after significant authentication events to prevent session fixation. So that is probably the best piece of advice in this list. All right? So let's consider a little scenario, right? Where's the eraser? There it is. So let's consider a little scenario, right? Let's say that person A is a good person who pays their taxes and never double parks, and person 2 is a mean hacker who always steals candy bars from vending machines. Person A has their session, right? S for session. Person B does not. Our hacker does not. Somehow, maybe an XSS attack, that cookie is stolen by the attacker, and now they have a duplicated session. Right? So far, so good. If you never regenerate your session IDs, this basically persists until one of the two of them breaks the session, probably by logging out. Right? You have to invalidate the session in order to end the hacker's access. Right? Which, by the way, is the reason all of your logout or all of your banking pages logout screens say, you must log out, please clear your cache too, right? The reason they ask you to clear the cache is because clearing the cache deletes the cookie on your machine, right? So let's say, just, let's say one of the things that the cookie does, one of the things the session does, is it keeps track of when the cookie was issued, and let's say every 5 minutes, the next connection resets the cookie, sets a new ID value, right? Of course, this is still client-server communication. Who initiates communication in a client-server environment?
Clients.
The client 100% of the time. So the server can't just reach out and fix someone's cookie. The server has to wait for the client to connect to the server. Then it can reissue the cookie, right? So, in that scenario, let's say that the server has decided that cookie is expired and needs to be replaced. One of two things happens. Either the first person to connect is person A or person B. Either our good citizen or our hacker. So, what happens if the first person to connect to the server is our good citizen? Well, the server issues a new cookie. Cookie 2. There you go. Cookie 2 invalidates cookie 1, thus invalidating the hacker's session. The next time the hacker tries to connect to the server, their cookie won't work anymore because it's not the current cookie, right? So that ends the hacker's access, right? The hacker gets kicked to the login page. Sorry, that's not a valid session. And they only have so much time. Basically, the amount of time it takes you to regenerate that ID is the amount of play time that they get with your account. After that, nothing more. So, regenerating IDs is a very good idea. And it costs you nothing as well. So that's scenario number 1. Our good citizen is issued the new cookie. What about, this is supposed to be a server lights, there we go. What if our hacker connects to the server? Well, the server can't tell the difference between these two. So, the server issues cookie number 2 to our hacker. This is probably suboptimal, but it's not as bad as you think. If the hacker gets a new cookie, what happens to our good citizen's connection?
Terminates.
It terminates. Yes, very good. So, exactly the same as the other way around, right? So, if our legitimate user is kicked out of their session, what are they probably going to do?
Get my cookie.
Yes, exactly. So, for example, let's say you were, you were logged into Big Al's Spring Emporium. You were shopping online for springs. If you were just kicked out to the login page, you would think it was some kind of error, and you had work to do there, right? So those springs aren't going to order themselves. So you log back in, right? You have the ability to log back in because you have the username and password. The hacker does not in this scenario, right? So, this person, their expression changes to You know that emoji with the person thinking? You know? Logs back in, right? Connects to server, says, hey, wait, my cookie was supposed to be good. What's going on here? Server's like, oh, yep, okay. That's another login. Issuing a cookie. Cookie 3, cookie 2, now invalid. Ha! We just invalidated the hacker session. So, when you regenerate the ID, it actually doesn't matter who ends up with the regenerated ID, so long as the good citizen can be relied upon to act like, not just take getting kicked out. It's like, it's like, oh shucks, the server kicked me to the login page. I guess it's time to go, launder my drapes or something.
Could
Yes.
they not just pass on the second cookie to the user that wanted the cookie?
Well, see, that's if you did that, it would be less good security practice, for sure.
No, I mean like the hacker gets the updated one, because they log in first, and then they pass it on to, B gets it, and then passes it on to A, to maintain. They basically spoof the fact that they're the server.
Yes, I mean, this is definitely a scenario that could happen if you programmed the server to work that way. However, I will add to regenerate cookies. If you receive a login attempt, regenerate the cookie. And that will prevent this scenario happening. But you're right, if we accepted a login and then that login, didn't modify the cookie value, it just kind of accepted it and moved it along. One way that you can, one scenario that you could see that would do this is if all that logging in means is that you have a variable in the session that you turn true, right? This is now a secured session. That vulnerability would still exist, absolutely. You should pair it with regenerating the ID. Honestly, if you want to be as secure as possible, I would almost recommend regenerating the ID every single time the user is sent a packet. It doesn't cost you anything to do, right? Literally all you're doing is you're updating in the session database what ID is associated with that session, right? It costs you very little to do it, and the security benefit of frequently regenerating your ID is very, very high, right? So, yeah. Does that make sense? Question?
So, while the hacker has, cookie 2.
Yeah.
And, the hacker has cookie 2 right now, and then our good citizen is kicked out. He's back to the login page. He logs in again, and if he successfully logs in, he now has cookie 3. Cookie 2 is now invalidated, right?
That's right.
So, if the hacker is able to change the password before our good citizen logs in again,
then good citizen is locked out of the account permanently. Yeah. So, again, but to some extent, the hacker, that's the first thing the hacker would try when they had cookie 1.
Oh.
Right? That's, if you're hacking, not that I'm giving advice on hacking into accounts or anything, guys, but the thing that you should expect from a malicious actor is that the first thing they try is attempting to lock the account. Yeah. I mean,
movies.
if you can accomplish that, then the entire account is yours, right? That was definitely possible for cookie 2. Cookie 2 will probably have a pretty short window, as long as person A is reasonably fast without entering their password, right? But again, that was possible with cookie 1.
Oh, okay.
Yeah.
So once that happens, there won't be a cookie 3 because he can't log in anymore.
Exactly. All that this guy would get is authentication failure. What they would likely do then is if it's a
Forgot
company.
password? Forgot password?
Yeah, there are a couple of different branches from there. What they'll typically do is like, okay, email backup. I forgot my password routine, right? That takes longer, right? And it assumes that the hacker hasn't changed the email address, right? So, if any of you in this room are in a situation where you are kicked out of an account to something, you try to log in and your password doesn't work, and then you try to get the, you try for the email address to do the forgot password process, and that doesn't work, right? Contact customer service and hope to hell that you can convince them you are who you say you are, because your accounts are currently being drained. That's what's going on. So, yeah. Make sense?
Yeah, and
Yes.
another question. You said that a good time to regenerate association IDs is when you receive new, how do I put it, like when the state changes, maybe you receive new information, you update new information, you know, when, I don't know, I'm thinking states,
Yes.
like whenever states changes, even though I'm not really sure what I'm saying.
Yeah, so, yeah, like, to put a concrete example on it, say you were doing like some kind of Twitter-like web application, like maybe you don't want to regenerate the ID every time you call for a new batch of posts in your feed, but like if someone clicks to post something, like regenerate at that point type thing, you know? Like when you're transitioning from one kind of activity to another is the advice that's given here. My advice would be like, why wait for that? You know? Again, it costs you almost nothing to regenerate the ID.
And you can never be too secure.
Yeah, exactly. And like the other thing is, the other thing that's configurable is the number of, like the size of the encryption key, right? So if you look at the PHP session, PHP sesh ID, it seems a little small in comparison to some you'll see, right? I think it's like, 16 characters or something. If you want to pop that up to like 32, 64, 128, that's configurable. The larger that number is, the less the probability is of session clashing. Two people randomly generating the same ID. Like at 64, you can probably wait from now until the end of the universe many, many, many times over and it won't happen. Just from the probabilities. So, but if the ID number itself is sufficiently small, you might run into like a problem with session clashing. But that's really more like simultaneous users logged in rather than, the IDs themselves. Make sense?
Yeah.
Cool. All right. I think that's all I have to say on the subject of security. If anybody has any questions, I'd be happy to answer them. Those were some very good questions. Shall we talk about databases? Very good. So, in this room, most of you, I'm not sure, have you taken the databases course? Yes? By show of hands, is there anybody who has not taken the course on databasing? Okie dokie. Well, in that case, I don't have to cover CRUD operations then. So, let's see here. So, before we talk about databases proper, the way that you're supposed to access, like the current modern way of accessing databases in PHP, a thing that is far from a current and modern language, is using the PDO object, PHP data object. The O in PDO is redundant. like ATM machine, right? But anyway,
Or like PHP.
hmm?
Or like PHP.
Well, I mean, some would argue the whole language is redundant, but you know. Yeah, like, you guys know what PHP actually stands for?
PHP, what?
Hypertext Processor.
Hypertext processor.
Yeah. You know what it used to stand for in the 90s? Personal homepage. Yeah. Right? That's kind of nice. You know, it's a little, it's very homey feeling. You know, you used to, in the 90s, you used to talk about home pages. These days, you don't really talk about home pages because nobody wants to live on the internet. Good grief.
Sorry, could you repeat again, why do we need the PDO?
So, there are older ways to connect to databases. They do not have the security features that the PDO object does. So, basically, when you're using PHP for assignments or in your general work life, if you're not using the PDO, you are introducing security vulnerabilities. Of types I will be happy to explore, but basically we're trying to prevent SQL injection attacks, right? Everybody knows what an SQL injection attack is? Yeah, good. So, the, you know, SQL injection attacks are very important. They are overall the most damaging type of attack that exists on the internet. Most of the big leaks and hacks that you've heard of were SQL injection attacks. Like with an XSS attack, you were attacking one user. With an SQL injection attack, you were attacking all users, right? That being said, the PHP data object is an object. Object. We haven't really been talking about object-oriented in PHP because it's awful. Very bad. Just like in Python, it's very bad. It doesn't work very well because it's a dynamic language. I would also say that object orientation in JavaScript sucks, but it is what we have. So they don't really cover object orientation in Python, right? Yeah. So Java is a nice language. When you do object orientation in Java, you write a class, right? You write methods for the class, you write instance variables, static, instant, public classes, private classes. Everything is like, well, laid out and nice and neat, right? But even more importantly, checked. The Java compiler checks to make sure that your classes are being used the way they're supposed to be, that you're not giving them the wrong data, and also that they're being instantiated correctly. And when you make an object from a class in Java, you can be sure everything you've said is supposed to be there is in there, right? You don't have to worry about, oh, I declared a class, but this parameter is missing for some reason. You don't have to worry about that in Java. Java is a nice language. It does what you tell it to do. Now we take a journey down into the dark, dank depths of the dungeons to discuss the dynamic languages. The dynamic languages, a lot of them don't really have classes in the proper sense. Like in JavaScript, for example, you don't really have such a thing as a class definition, right? The best you have is a function that works as a constructor. That's what you have in JavaScript. You have a function that if you use it like a constructor, it's a constructor. That's JavaScript. In PHP as well as in Python, you can declare classes, right? But class definition doesn't mean what it means in Java, right? It doesn't mean that the thing's being checked. It doesn't mean that the thing is necessarily even consistent. Because these are dynamic languages, you have to have the ability to add things to objects on the fly while the interpreter is interpreting, right? It's just due to the nature that we don't have anything precompiled, right? We don't have anything precompiled. Everything is being fed into the interpreter each time. So the interpreter itself doesn't know how long your class definition is until it reaches the end of it, right? So you can declare a class in PHP or in Python. They work similarly. You can declare your class, you can make objects from it, and then you can add new attributes, you can add new methods to these objects on the fly dynamically. You may find this useful, but mostly it's just a pain, in my opinion. There's also kind of an open question whether like private or public is even like useful to be included because it can't really be enforced. So, you know, good grief. Yes.
Did you publish that?
Oh, is it not published? Let me take a look. Modules. Ah, there we go. There we go. So, I'm not as intimately familiar with the details of PHP in this respect, but with Python, all that private means is that they're name mangling the name of the private thing with the class name, and that's it. You can actually access private members with full access. You just have to know how the name mangling works. And here, I'll show you. It's like this. There you go. I just gave you full public access to anything Python claims is private. If you just say object, what is it? It's object dot underscore underscore dictionary underscore underscore dot, and then that gives you public access to anything that Python claims that it's private. It's ridiculous. It's a ridiculous system. So, in PHP, the way that objects work, you can define a class. You define a class by opening up a class similarly to how you would do in Java. You then drop functions into classes. So, you know, typically when we're talking about objects, objects have methods, not functions, but this is not the case in PHP. In PHP, objects have functions and not methods. But you just, you know, write your procedure, give it a name, and then you can access it through a very confusing set of syntax. So, one of the design impulses of PHP was that every symbol should not do more than one thing, right? How do we concatenate strings in PHP? Yep, with dot. Why do we use dot? Aside from we just do. Yes?
Because plus is for integers.
Yes. Yes. The plus sign is for arithmetic. Dot is for concatenation because plus sign is for arithmetic. And unlike, you know, pretty much every other language, PHP doesn't like overloading plus with string operations, right? But what does everybody else use dot for?
Decimal?
Well, I mean, yes, but
Full stop.
in a non-numeric context.
Full stop.
Hmm?
Full stop, period.
Well, in a spoken language or a written language context, yes. If I were to put the dot character in JavaScript, what would I be doing? What operation?
Oh, to access the methods or the properties
Of things.
of things.
Most things in JavaScript, actually. Yes. So in most object-oriented languages, dot means member access. That's how we would say it in C++. So, you know, I'm using one right here. Twice, in fact. Object, dot, dictionary, dot, class variable, right? Dot is accessing stuff. But in PHP, what does dot do?
Concatenates.
String concatenation. And PHP hates it when things do more than one thing. So, you ready for this?
Oh,
That's a good reaction. It's hyphen greater than, single line arrow. This is your access operator for things inside of objects in PHP. Note, you only include the $sign on the first of the things. All right? You guys want to know what $sign like actually is, aside from a thing that's stupid that you have to memorize?
Yes.
It's a memory access operator. Most languages let you access memory for free. You don't need an operator for it because every time you're accessing memory. But no, in PHP, well, and also because PHP thinks it's bash is another reason. In bash you have $signs all over the place, but only when you're reading variables, not when you're assigning to them. It's like, I am reading this, and it's like, it's there because bash is kind of a weird language, like literally everything is a string. Like there's no data type other than string unless it's inside of like a program. Anyway, bash is great, but also very confusing. So yeah, arrow. That's how you access things from objects in PHP. Would you like to know where the heck that came from? Because it actually does have some ancestry. Anybody care to guess what language that comes from?
C.
That's right! It does come from C. Very good. So, in C, there's a very, very confusing thing that everybody hates called a pointer. Right? So, pointers are references to memory. Rather than being memory themselves, they refer to a cell in memory. So the value of a pointer is a memory address, right? So if I have memory, right, and I have, the value 60 held at address 800, if x is equal to 60, then a pointer to x, this is the operator, pointers, would be 800, right? Okay, fine, sure. Gets very confusing very quickly, even though it seems simple, right? Here's the thing. C also contains a thing called structures. So C doesn't have object-oriented programming because you can collect variables up into a single thing in C. That's called a structure, but you can't package it with functions or methods. All functions and methods are just kind of hanging out in space. They're not associated with structures, although they can, they're only associated with structures insofar as they take a value of the structure type as their input. But anyway, when you have a structure in C, they kind of look a little bit like this. X, Y, Z, 5, 10, 15, can kind of imagine that in memory, right? If this is a pointer, if A is a pointer to a structure, is it A star, star? I don't know, it's been a while, it's been a number of years since I've done C. Dereference A, get this. It's like in C, A dot X would give you 5 so long as A was this thing itself. But if A is a reference to X, instead you have to do A arrow X, right? So like, it's like an obscure C thing when you're working with pointers rather than direct references to structures. That's how you get the members out of them. And apparently that's the closest thing that PHP considered to direct accessing of things from objects, even though structures and objects are really not the same thing at all. Although, you know, in an object-oriented language, you don't really need explicit structures. You just make a class with no methods. But anyway, so that's where it comes from. When you want to access the methods or the attributes of an object in PHP, you use arrow. Yay! Any questions? Cool. So the general line in this class is, I'm not really going to expect you to make classes in PHP, but you're going to have to know how to use some objects in order to do databasing. Okay? Fair enough? Good. Still, the class wouldn't be complete without some treatment of it. I don't think that it even had, like, I think that PHP didn't even have objects until like version 5 or something, like quite late in its development. And even then only on sufferance. We're kind of pulling from the Python paradigm. In Python, when you have the quote-unquote magic methods, which is what it calls constructors, it will prepend and postpend, append. It will prepend and append 2 underscores on either sides of things in order to make that. Okay, that's the initializer. PHP does a similar thing. It's throwing a lot of underscores around. I don't think that, you know, if everything goes well in this course, you'll never have to write a class or a constructor, so it'll be fine. Yes. Any questions? Shall we talk about databases? Ta-ha! So, I'm just going to double check that everybody's been through the databasing. What's that course called again? Like database theory or something? Yeah. Yeah. If you've taken the class on database theory, then I'm going to assume that you're good with knowing what records are. You guys, everybody knows what a table is?
Yep.
Right? Everybody knows what a record is?
Mm-hmm.
Everybody knows what a select query is?
Yeah.
Insert?
Yeah.
Delete?
Yeah.
Update?
Mm-hmm.
Wonderful. All right, so we can just skip this stuff then. All right. So, I apologize for this lesson being somewhat theory heavy, but you know, I always think it's better to present the theory before the practical example. That way you might have some idea what you're doing as you're doing it. So, we can talk a little bit about what servers are. I know it seems a little late in the course for that, but it hasn't really been relevant before now. So, here's a question for you. Is a server a software or hardware?
Software.
It's software. That's right. Most people think of servers as being those great big, you know, clunky machines that you see on server racks, right? Nay, nay. Those are computers. They are running server processes. servers are software processes, right? So, when we connect to a database, we are not connecting to Microsoft Access, right? We are connecting to a server. The database is a server. So, when we have our PHP web server connected to our SQL database server, we will most of the time have two server software processes running on the same hardware, right? So, for example, let's say we're doing this with XAMPP, right? With XAMPP, we have our client software, Internet Explorer, Netscape Navigator, you pick. The client is sending packets to the network infrastructure, the sockets. You guys know what sockets are? Yeah, that might have been covered in intro networking, right? Yeah. So,
Can you summarize it?
Hmm?
Can you summarize it?
Absolutely, that's what I'm being paid for, absolutely. Yes, so I will summarize by analogy. So I assume that most people have been inside of an apartment building, right? So normally within the lobby of an apartment building, you'll see a wall, which is a bunch of different cubbies, right, that people receive their mail from, right? Bunch of numbered slots, mail gets put into them. This is roughly the same thing as the port apparatus of a computer, right? So, for example, normally, like at least when I connect to XAMPP, and I'm connecting with the browser, I have to specify what port I'm accessing because XAMPP is like listening to messages from one particular port. Typically, that's 1080 on like these machines. If it's on your own laptop, it might be something else. So the client takes a network packet and it stuffs it in to port 1080. We then have XAMPP running two processes. First, our web server. There we go. The web server is configured to listen for messages on some particular port. It tells you, like the XAMPP control panel tells you what port it's listening for. It's listening for 1080. So if any messages that get stuffed into that cubby hole, it has the key, opens it up, takes out its mail, bills, jury duty, bills. Ah, there's the message. The web server then produces an outgoing response packet, places it normally into a different port. I forget what I think it's 443?
Yep.
Yeah, there we go. And then that's the one that the client is listening on. And that's how the network, that's how the ports work, right? Port addressing summarized. Now, when it's XAMPP, the thing that's listening is inside the same machine. If we are connecting to the internet in general, those packets are going out this way into network architecture and infrastructure. All that wibbly wobbly stuff that we don't have to worry about because we're in the software stream, right? Everything on this side is our responsibility. Everything on that side, that's networking, the networking program's responsibility, right? So, in our case, since we're using XAMPP, we tell the computer that we are looking for something on the same machine by specifying it as localhost, right? So the web server, with respect to this guy, is located at localhost, right? So now we need to connect to a database server. The database server will be another software processor running on our machine, an SQL server. Incidentally, SQL is also a packet format, as well as being a language. So, the client will not usually connect to the web server directly. In fact, it should never do that. It should never, ever do that. The SQL server will require login credentials, right? It must be secure. Login credentials on an SQL server gives whoever has those credentials the ability to do lots of databasey things, right? Never trust the client, right? If your client is logging in directly to your SQL server, then you don't even have to worry about SQL injection attacks. You've literally rolled out the red carpet for them, right? So, communication between the web server and the SQL server actually operates the same as it does between the client and the web server. The web server creates a packet, sends it to the network, sends it to the socket layer. The SQL server is listening for a particular socket, receives the packet, process, sends back the response. That's being listened for by the web server. It gets sent back. The web server receives the packet, and this will most of the time be the information you were trying to look up. Or like a syntax error. You goofed up you goofed it up, syntax error, this is an error. Otherwise, the data you were looking for. Although sometimes the data you're looking for is the absence of data. It's sometimes useful to look up in the database to see if something isn't there, as well as seeing if something is there. So, does that make sense? So that's the case with XAMPP. Or similar systems where you're doing things through localhost. Docker containers. Same idea, right? What about CS Unix? CS Unix is a server we must connect to through network infrastructure. So, for CS Unix, we have our client communicating with the socket layer. It goes off into cloud, not the app, not the cloud, just it's just a visual device to indicate lots of network stuff we don't care about. The cloud is REST APIs are what the cloud actually is. You know, it's not an actual cloud. So the server machine will have its own socket layer. It will have its own web server, right? When you plop stuff down into public HTML, the web server is looking for it there, right? Web server absorbs packets, and then it has to communicate with the database server. The database server is, of course, located on CS Unix as well. SQL. Once we are within the server, we are actually performing the same routine that we were over here. Because the SQL server process and the Apache web server process are both located on the same physical machine, in the case of CS Unix, these are local hosts with respect to each other. Right? So when you write your PHP script, attempting to connect to this SQL server, you will be attempting to access localhost, even though it's not localhost with respect to the client. Does that make sense? Good. So there's a third scenario, right? This will do you for like, small to medium-sized web applications, right? Although, people rarely have their own dedicated server hardware anymore, right? Most of the time you're using cloud and that type of thing. But let's just assume, for the sake of argument, that it's currently 2006 and you have your own server, right? Let's say that you're not a medium or small business. Let's say you're a large business, right? Let's say you're dealing with a lot of SQL queries, right? It would often make sense to detach your SQL server and put it on its own dedicated machine. In that case, your SQL server is no longer localhost with respect to your web server. This is probably also going to be the case in the cloud. So it depends on how things are configured, I suppose. But just be aware that when you guys actually get out there, you could be dealing with either of those scenarios, and it depends on how old the company is, whether they own their own hardware, how much cloud they do, all kinds of stuff. You could be in either scenario. Does that make sense? So, yes. So when we are connecting to the database, right, we are opening a network connection with the database in the same way that the browser is opening a network connection with the web server. Right? That's like, it's important to understand that the database is not it's not some feature of the Apache server, right? The session database is. The session database is run and administered by the Apache web server. It's self-contained. It's located inside that thing, the session database. But if you want, just general SQL database, that's its own server process. Okay? Have I whipped the dead horse sufficiently at this point? Good. So, if you don't have it running already, if you could please load up XAMPP. Something I myself forgot to do, I think. If there's anybody in the room who wasn't here on Friday, who didn't hear this warning, I will reissue the warning. When you're using XAMPP, the directory that all of your files are in, as you can see, the XAMPP folder is a folder in the root directory of the machine, which means any logged in user can access all of those files, which means, in practical terms, if you are doing your assignment on lab computers and you leave files lying around inside here, the next person to log in knows where to find them. And that may result in charges of academic integrity, because, you know, if somebody's submitting an assignment that they find lying around on a lab computer, they're probably not modifying it a lot before they submit it, right? So just protect your data. When you're finished working, delete. Empty recycle bin. Okay? Good. Like you can see, look at all this stuff. Did I make one page.phge.php? No. Probably Steve did. So, let us take a moment to consider the XAMPP control panel. Thus far, we have used the Apache server. We have not used the, it's all good. Just don't knock it over, okay?
Yeah.
We have not used the SQL server. Please fire up both of those. There we go. Very good. So, before we even dream of considering attaching a PHP process to the server, to the database server, we need something in there to attach it to. My SQL module has an admin button. If you click on it, you will be brought to PHP MyAdmin, like so. This is the interface through which you can configure the database itself, the server, the tables. You can run SQL queries through this, you know, server administration. So, this is going to look a little bit different here than it does on CS Unix. So, the SQL server contains many databases, right? We have a few of them here, but we have, you know, the ability to make more as well. We have the ability to make more here because your privileges on XAMPP are unlimited, right? It's your machine. On CS Unix, you do not have unlimited privileges because that would be silly. If you had unlimited privilege on, wait, hold up. Did they have you use the SQL server on CS Unix for the database course?
Not yet. No.
No? You would just like, was it Microsoft Access you guys were using or something
SQL Server.
Microsoft? Hmm?
SQL Server.
SQL Server? Okay. And was it a live server? Did you have to deploy
Yes,
anything?
yes, you did.
Yeah.
It was MySQL server.
Okay, alright. Did it look anything like this?
No.
Okay. So this is still useful?
Yeah.
Okay, alright. So on CS Unix, you will have a database which is yours. It will have the same name as your student, or well, you know your CS Unix login username. If you go to PHP MyAdmin, you'll see like the big list of everybody, every student in the last like 20 years' numbers, right? So actually, I'm not sure how frequently they delete them, but you only have privileges for your database for obvious reasons on CS Unix, right? But here you've got free reign. When you are, and this is a rather important step. When you are working on your assignment, that relates to databases. A step that people often miss is reconfiguring the connection details from the working XAMPP version that you have for CS Unix, right? You have to change the login information, otherwise you can't access the database, and like, if you can't access the database, like that's the first hurdle, in a sense, for that assignment, so, you know, if you can't even manage a database connection, you need to do that, otherwise you won't be pleased with your grade. So, yeah. So you can call it what you like here, but when you transfer it to CS Unix, there's a name that you have to use. Okay? So, let's create a database. What shall we call it? It's like, what do you call this variable type of problem, right?
Database one.
Ah, I like that. I like that. Database 1. Love it. So don't worry about the fact that it seems to be in both Latin and Swedish. That's actually not true. It's just the character set. Just leave it at defaults and create. And there you have database 1. Database 1 is created with no tables. We must create some tables. Or at least one table anyway. So, what are we going to do today? Video games? You want to do video games?
Sure.
Sounds good. Video games. Number of columns. Yeah, 4 is probably fine. Doop. If you click Go, you will be brought to this rather uncomfortable looking web form. Each one of these rows you are essentially using to create your database schema, right? So, in the case of video games, we should probably have a title. We might have a genre, and maybe we have a rating. Title and genre, let's make those varchars. Size 64, I guess. Genre, we shouldn't need more than 32 characters. You'll notice I left the top one blank. That one is for our primary key. ID. So, there are lots of different options that you can set here. Pretty much all of the different things that you explored during your databasing course will be represented here in some way or another. You know, required, fields, primary keys, all of that jazz. Setting default values, all of that type of thing. One thing that I'd like to call your attention to, which sometimes surprises people, is this checkbox here, A_I. This is not AI in the current sense of the word AI. This is auto-incrementing. So if you click this checkbox, it saves you the trouble of having to read and update and find unique primary keys for all of the entries that you enter. Does the one that you were using before, did it do that? SQL Server?
No.
Well, then this one's better. Ha! If you click this, there you go, and click Go, just leave default values. It will automatically tag it as primary, and yeah, basically whenever you write values into the database, you no longer have to provide an ID. It will automatically give the next available. Make sense? So if we save that up, there we go. We are now brought to the structure tab. Within the in the database, video games table structure tab gives us the schema. The browse tab shows us the actual honest to goodness data stored in that table. This can be very useful, probably, like I'm just kind of spitballing here, but probably when you guys were working with the SQL server, you got to see the actual data most of the time, right? When you're programming a PHP script to interact with the server, like you only see, primarily, you only see what the PHP script sends back to you, right? The whole point of having that middleman layer is that the end user can't see what's going on in the database, right? So this becomes like a very important go-to point to view how the database is being modified, for example, when you're debugging your program, right? Make sense? So, very good. We also have the SQL tab. Let me see if I can increase the font here a little bit. There we go. So, here you can enter just plain old SQL and execute it on your database. Any questions so far? This should be fairly. You guys should feel pretty grounded in this. You know, this shouldn't be too different from what you've already done. Yeah. Okay, good. I will give you a quick tip. These buttons here give you auto-formatted common operations. You know, you can see your CRUD operations in there. In particular, phpMyAdmin seems to be a little bit picky about backticks. You see these here? Those are not apostrophes, those are backticks. All right? Sometimes it requires them, sometimes it doesn't. It can be a little finicky about it. My recommendation, if you want an insert query, which we definitely will want later on, you click on that, it puts all the right stuff in all the right places. Modify this to form your query, and then put that in your PHP. If you're wondering where we're going with all of this, the SQL query gets encoded as a string in PHP and sent along with the packet to the database where it's processed. So you'll be, at some point, copying and pasting this into PHP for use in the PDO object. Don't worry, we're going to do the whole, we'll do all of it through. Yes?
Are we connecting multiple tables with their keys, or is that just not?
We're not going to be doing anything quite so complicated in this
Okay.
class, actually. We're not like... So this course is usually taught concurrently with the database theory class. So I can only really feasibly accomplish what it doesn't take very long to go over in class, and that basically restricts us to CRUD operations. So no, we're not going to be doing anything fancy. You learned how to do something fancy in the other class.
Thank God.
Yeah. But all of that fanciness that you learned in the other class is still applicable here. But you know, when it comes to like taking database operations and translating them to like stuff in web applications, you'd be surprised how far you can get on just CRUD operations. It's quite good actually. Like even just the basics get you a long way, you know? Anyway, let's populate a little bit of data just to have something to work with. What is the name of a video game?
Halo.
Halo. Genre? Action, I guess. Rating?
Classified.
Classified. No, it has to be an integer. Okay, this is how we're going to do it. Everybody who likes Halo, put up your name. Put up your hand. Okay, we got 1, 2, 3, 4, 5, 6, 7. Rating is 7. There we go. Go. There we go. One row inserted. Go to browse, and you can see, there you have it. Let's add a couple more just to fill out the table a little bit. You'd be surprised how many times people like Halo is often the first one I hear. And I don't think like has Halo even had like a good game come out recently?
No, there hasn't been a good Halo game since like 2010.
Yeah.
We just old,
We just like, yeah, no, it's all good. It's all good. You know. If you asked me, I'd probably say something on the N64, so that's how it goes. How about another video game?
GTA?
You said the last one.
Okay.
Someone else.
Fortnite.
Fortnite. I don't care, they spell it wrong. Genre?
Same as the last one, action, I guess.
Same as the last one, action, I guess. Very good. That might be too many characters, but we'll go with it. How many people like Fortnite? Whoa. Okay. Why even suggest it? Alright. And we'll do one more. What's a video game?
Minecraft.
Minecraft, okay. Not Micecraft, Minecraft, there we go. Genre?
Sandbox.
I said, I heard sandbox and exploration, so sandbox exploration. How many people like Minecraft? 1, 2, 3, 4, 5, 6, 7, 8. All right, 8 it is. My wife likes Minecraft. I like Minecraft too. I should have counted myself. It's like, whether you like it or you don't, it kind of like doesn't even matter because it's so like ingrained in the culture, you know? Yeah. Good. So, yeah, we did get cut off there. Same as the last one, action, I do. So, we have data. Shall we see how to load this data into a server? By which I mean a web server. It is actually already loaded into the database server. Yes? Any questions before we do? Yes?
I'm having an error where it will not, even though I type the same data format by clicking the insert button into the data table, it just will not accept it.
Mind if I take a look?
Sure.
This is the one that counts?
Yeah, I have, if I take the.
We removed ID from here.
Ah.
We wrote them up here.
Oh, okay.
So
Yeah.
like-
Because it's a primary key, you don't have to include it.
Okay. Alright, thank you very much.
No trouble. Anyone else having any difficulty? All good? Very good, very good. Good. So, our object now is to write a PHP script which opens a connection to that database. So, we're going to be doing this inside of our htdocs folder. Where is it? There it is. Oh, I hate Microsoft so much. Okay. I hate Microsoft because it treats you like a child.
Do you know why the school computers don't have the name extensions on by default? It's really annoying.
Because it's not for you, that's why. It's a general purpose computing lab, that's why. Like you want information? Go find it, you're smart. Alright. Let's go to, yes, this one. Oh, no, not that one. That was from earlier today. Before lunch, I teach JavaScript in the same room. I know, right? JavaScript. It's taken a while, but I have actually come to despise JavaScript even more than Python. Let's see here. We'll call this connect.php. Alright. So, to access that, localhost. I put it in the folder with the date, 25-07-07. There we go. We've got connect.php in there. Clickety clickety. Does nothing because it has nothing. Very good. So, in order to connect to the database, we construct the PDO object. Now, constructing the PDO object is an operation that might fail with an exception. Now, you will find in PHP that exceptions aren't used for an awful lot because, just like object-oriented programming, it only contains them on sufferance. But we have try-catch. We need to start off with a try-catch. Now, you'd think that the number of times I've taught this course I'd have this memorized, but I don't. There we go. So this is the example code in the notes which does work. We declare a new variable. In this case, it's called DBH for database handle, which is a perfectly adequate name. We declare a new PDO the same way that we would in Java. Our parameters, though, are a little interesting. The first parameter is telling us what database server to connect to and what database within that database server we want. So, MySQL host is equal to localhost. That will never not be the case for us in this class. On XAMPP, that will be a localhost. On CS Unix, that will also be localhost. Because it's where is this thing located with respect to the web server. Next, DB name is the name of the database which we assign. If we take a look, we call this one database 1. database 1. There we go. We want that inside the string though. There we go. And that concludes the first argument. Sometimes when I run out of space, that's how I do my arguments. It's the same, it's just white space, guys, but it makes it a little more readable in my opinion. Plus you can like leave line end comments in it easier. The next thing is we need to include the username and login information for the database. If we are running on XAMPP, username will be root, password will be empty. If you are running on CS Unix, it will be your CS Unix login credentials, or you'll have to talk to IT to get it reset. That one's not my job, that one's their job. Getting your SQL Server credentials reset, that's their job. So, trust me, it's like a whole open debate why that should be our job anyway, when they administer the server. So, my ID becomes root, password is blank. Make sense? Good. So, after this, you basically have the catch, exception, E, very similar to Java. Now, using die should be avoided in production code, and yet it's here. So what we do by calling the die function is we impart def on the PHP process. All right? It kills the process. You should probably not do that. You should use exit. Did Professor Adams show you the exit function?
No.
No? Really? Okay. It does what it says it does. It terminates the process. The number here is the status code. So basically, like the majority of the time, you'll just want to put a 0 there. It returns exit status 0. If you want to send information to the server that the PHP process ended abnormally, then you would put something non-zero in there. But this is not information to your user. This is being sent to the server, right? 0 is appropriate in the overwhelming majority of cases. For example, when the PHP process has a syntax error, that's a case where that process exits on something other than 0, right? So, you guys know about return statuses, exit statuses? No? Okay. So, this is a Linux server. Linux servers are based on Unix, the Unix paradigm. The Unix paradigm is based on streams, right? So the idea is a program is a process inside of a stream. It consumes some data from the stream and it puts some data back into the stream, right? Exit statuses are the way that Unix programs report whether they crashed out on an error or if they ended normally. 0 means I ended normally. Anything other than 0 is an error code that you have to look up in one of these great big, one of these great big user manuals from the 80s, right? Non-zero exit statuses are like, for example, if you're trying to compile a program and there's a syntax error, the compiler stops non-zero exit status, right? So you can set that. There it is, right there. Very good. On a related note, what about HTTP response status codes? Did he show you those ones?
No.
You learned it yourself. What a shame, because this is a class it's supposed to teach that. Oh man. Because this is a situation where we would want to send a bad status back to the client, not to the server, right? Yeah, we are running out of time. A little rude to leave 4 minutes before class ends, though. So, let me just, yeah, it's just HTTP response code. So, if you put in HTTP _ response _ code, that basically sets the response code value in the header. So in our case, we would want to look up to see what kind of response would be necessary in this case. HTTP status codes. There you go. This one's good. This would be probably a server error of some kind actually, because the server couldn't connect. So yeah, 503 service unavailable might be a good response code in the case where the server can't connect to the database, right? There might be one here if you read the list which is more appropriate, but 503 probably does it.
You wanna try 418?
418? Yeah. Okay, here's one for you. HTTP status kittens. HTTP. Have you seen this? HTTP cats? It's a cat photo for every HTTP status. Bad request. Unauthorized. Payment required. Forbidden. Not found. Method not allowed. And of course, everybody's favorite, I'm a teapot. So, anyway, unfortunately, in the remaining 2 minutes, I don't have enough time to actually send any requests to the server, but hopefully next class we'll be able to pick up from here. Sound good?
Yep.
All right, thank you very much. See you on, it's Friday, right? Or is it Thursday?
Thursday.
Thursday. See you on Thursday.